Section 1.6 today, we're going to talk about relations and functions. Okay, this is straight out of Algebra 1, relations and functions. All right, so it should be a lot of review for you. A couple key terms, vocabulary-wise. But then after that, it's pretty straightforward. All right, so relations and functions today, section 1.6. A relation. A relation is a set of ordered pairs. So a relation is any set of ordered pairs. So notice that an example there, 0, 5, 0, 4, 2, 3, 4, 0. A relation is any set of ordered pairs. 1, 1, 2, 2, 3, 3, 4, 4, 5, 5. Okay, that's a relation. It's a set of ordered pairs. 1, 1, 1, 2, 1, 3, 1, 4, 1, 5. That's a set of ordered pairs. That's a relation. Okay, so relation is any set of ordered pairs. They can make a relation. Domain. Domain is a key word that you need to be able to recognize. Do you remember hearing the word domain in Algebra 1? Good. Okay, domain is the set of all possible input values of a relation or function. Domain means it's all of my x values. Domain is all of the x values. Okay, so I'm talking about domain, I'm talking about my x values. Domain is the x values. All right? Now, range. A lot of times we think of range, a lot of times people think of like range with like central tendency, like the range of numbers is the biggest one minus the smallest one, right? Okay. Range of a function though, okay, range of a function is the set of output values. If domain is my x values, range is my y values. Okay? So domain is x, range is y. Two key terms there. Domain x, range y. Next we have the big one here, which is my function. A function is a relation in which every input is paired with exactly one output. Okay, so a relation is which every input is paired with exactly one output. I like to think of a function as like a vending machine. Okay, a function to me is like a vending machine. Alright? What I mean by that is when you go up to a vending machine, okay, you enter your money. You press the code A1. You get whatever comes out of A1, right? A1 is my input. The candy that's in A1, that's my output. I have one input, I get one output. That's my function. If I press B5, okay, B5 is my input. The chips that are in B5, that's my output. Okay, input output's like a vending machine. You enter a code, you get something back out. I enter something, I get an output back out. Input, output. Input, output. Okay, that is a function. All right. Now here's the key phrase though. It has to be paired with exactly one output. All right. So think about it here. When I have a vending machine, if I were to press A1 and there's a Snickers at A1, but there's like some Chex Mix at B5. If I press A1, can I get both of those back out? No, I'm only going to get whatever comes in at A1 actually. So each input has exactly one output. I'm never going to get two outputs from one input. Okay, that's a function. The x's cannot repeat essentially. All right, x's cannot repeat. One input for exactly one output. Again, we'll look at that here in a little more with some numbers. It'll make a lot more sense if you throw some numbers in there. So here's relations and functions again. So relation pairs input values with output values. Domain is my x coordinates. So domain is a set of values or x coordinates. Range is a set of output values or y coordinates. Domain x, range y. Kind of ingrain that in the brain right now. All right. When I'm talking about domain, I'm going to ask for domain here. Domain is the set of all x values. So notice here, I have the year. When I'm asking for the domain, I'm just going to list them out from least to greatest. So 1996, 1999, or 98, 2000, 2002, 2004. I list them. Notice I list them with squiggles on the end. That means it's a set of numbers. So the squiggle there represents a set of numbers. So it's the set of numbers, 1996, 1998, 2000, 2002, 2004. Same thing with the range. I use the squiggle, and I list out all of my range values then as well. And that is the set of domain and range. I can do the same thing on a graph over here. It's hard to kind of see the points. Okay. I can do the same thing on coordinates. Recognize my domain as my x values. My range. What do you notice about my range? I do not repeat values. So notice, technically I have two 2's here. Does everybody see that? The one is negative 2, 2. The other one's at positive 2, 2. Notice down here my range. I do not repeat it. Once it's in the set, I do not have to repeat it. It's already in the set. So if a number repeats, just only enter it once. Only enter it once in the domain and range. You do not need to repeat the value. Okay, it's kind of important to remember. So let's look at the first one here, number 1. It says give the domain and range of each relation. So the domain is my x values here. So there's my domain. I'm talking about the year. It starts off at 2001. What is the next value of my domain here? Jace, what's the next value of my domain? 2002. And then comes what? 2003. And then comes 2004. And lastly, 2005. Nice job. And I put that all within a set of numbers. All right, next comes the range then. So now I'm going to do my range. Range is my price. I start with 25. What's the next value, Kyle? So look at the price there. No, I start at 25. So I'm going to go least to greatest. There we go. After 28 comes. And then? Good. And I put all those in a set. So there are the set of domain and range for that table. Now I can do the next one here. I have coordinates. Okay, so there's my coordinates. I want to do my domain. If I want to list my domain from least to greatest, where should I start in my graph? Should I go top to bottom, right to left, left to right? I want to go left to right if I want to go least to greatest, right? Yeah, if I want to go least to greatest in my domain, I want to go left to right. So I started at negative 4, so I started here. What's my next value, Beast? And then? Negative 2, and then? And then? Good. All right, now my range. If I want to put, what?
What's that last one?
X values, bud, right? So negative 4 was here.
How do you get those?
Negative 3. Those are my X values. So do you notice here my X coordinate? Crump?
Yeah.
See my X coordinate down here?
Yeah.
So I'm going from left to right on that values. So I have negative 4 here.
Okay.
Negative 3 was here.
Okay.
Negative 2, negative 1, 0. So I just listed those X coordinates out of where they're at in the graph.
How do you know which one's X and which one's Y? Like which one?
My X is the horizontal axis.
Yeah, I know, but like, how do you know where to put the points?
Oh, the points are already there.
Okay.
I just, if you look at them here,
Oh, you're just.
I just blew them up so they could see them better.
All right.
They were already there.
My bad.
No, you're good. So there we go. Now I need the range. If I'm going to use my range, I want to go from least to greatest. Jake King, which way would I want to start?
Right to left.
Range. So range is my Y values. Rob? I want to go bottom to top for my range. So I started at negative 2. Rob, which one's going to come next? Negative 1 followed by?
0.
Followed by?
1.
Followed by? Good. There's my set of domain and range values now. All right. Let's try a couple more here. Try these two on your own. Okay, take a couple seconds, try these two. List the domain and range of both of these relations. All right, let's look at these here. Number 3. I want to list the set of my domain. Drew, can you give me the set of my domain here? The set of my X values.
1, 3, 5, 4, 2.
Ooh, how do we list them always? From
Least to greatest.
least to greatest. So 1,
2, 3, 4, 5.
2, 3, 4, 5. Nice job. Yep. Now, what about my range, Drew? Same thing here. I want to list my range.
It would be 2, 4, 5, 8.
I don't think there's a 4.
That's my bad. 2, 5, 6, 8.
2, 5, 6, 8. Now, notice something here. I had 2 5s in my set, right? I only listed them once in the range because once it's in my set, I do not need to repeat it. Okay, so notice. And yes, there were 2 of them in there, but I only need to list it once in my set. Okay, I do not need to repeat the values. 4, Crump, what's my domain here?
Negative 3, negative 2, 0, 1, 2, 3.
Nice job. Joe, what's my range, bud?
Range is the one.
Oh, yeah, Joe McCoolidge.
-2, -1, 1, 2.
I think we forgot a 0, didn't we?
Oh yeah.
0, 1, 2. There we go. And again, notice, we had 2 2s, but we didn't repeat them. Okay? We do not repeat values when they get in the set. Alright? Try these two as well. Same thing here. Find the domain and range. Take a couple seconds. Find these two on your own. Alright, let's look at number 5 here. I want to find the domain. Jace, what is my domain? -5, 0, 1. Nice job. What is my range, Jake King?
1, 2, 4.
1, 2, 3, 4.
Oh yeah.
Number 6, I want my domain. Allie, what's my domain?
Hold on. -1, 0, 2,
Nice job. And what is my range, Katie? 2, 7, 8. Notice, did we repeat the 2? Nope. There were 3 2s in the set, but I only list it once in my set. Okay, good work. All right, last thing we're talking about today is it a function or not? Okay, a function is a special type of relation. A function has only one output for each input. What that means is your x cannot repeat. Okay, your x values cannot repeat. A lot of times you can use a graph. You can use what's called a vertical line test. Now, vertical line test shows whether x is repeat or not. So if you notice, I have a line here. Now, vertical line test determines basically that if your graph ever touches your vertical line more than once, it is not a function. So look here. As I look at this graph, I'm going to draw some vertical lines up here. Does it ever touch any of those vertical lines more than once? No. So that means this is a function. That would be an example of a function. Okay, this is a function.
Same thing like a square.
What app do you use?
I used those, Harry.
Same thing like a square there.
What?
Like if they had a square there, that'd be a function.
Would a square? Okay, great question. Drew says, what if they have a square? Okay, would that be a function or not? Does it touch that line twice?
Yeah.
So that is not a function. All right, let's look at the next example here. All right, I draw a vertical line right here. Does it touch that vertical line more than once? Yeah, it touches it here and here. So that is now not a function. So this is not a function. I can draw it anywhere I want to.
It just, you can't hit it.
It just can't hit the whole graph. Along the whole graph, it cannot hit it more than once.
A vertical.
It has to be a vertical line. Yep, vertical line. All right. So we'll look at a couple more here. All right.
Whoa, wait, what?
So this is pretty
I was
easy.
down for like 1 second and I looked back up and a bunch of stuff.
So vertical line, right? If it touches the vertical line once, it's a function. If it touches it more than once, it's not a function. So the graph. So let's look at it now here. This is what's called a mapping diagram. This basically says where your x's are paired up with. Okay, mapping diagram kind of pairs it up. It says, is this a function or not? So this is saying -2 goes to -3. 0 goes to 0. 3 goes to -1. 4 goes to -1 and 3.
That would not be a function.
And 5 goes to 3. Crump, what do you say?
Not a function.
It is not a function. Why?
Because it passes through the line more than once.
Yeah, if I look right here at this 4, my 4 goes to 2 values. My x cannot go to multiple values. Every input can only have one output. X cannot repeat. Okay, key. Let's look at 8. 8, -4 goes to 0. -2 goes to -1. 0 goes to 2. 1 goes to 2. 2 goes to 3. Function or not?
Yes.
That is a function. Okay, and again, where are we always looking at? We're always looking at our x values. Okay, we don't care about the y and function or not. We only want the x values. Do any x values repeat there? No, no x values repeat. They don't share any number. That is a
So
function.
If the X value repeats,
If the x value repeats, it is not a function.
it is not. So on number 1, where's
The 4 here, the 4 goes to -1 and 3. So 4 has 2 outputs. So that means it's not a function. See how -4, bud? See how -4 has 2 lines going from it?
yeah?
That means it's going to 2 different outputs.
So that's all you have to look at.
Yeah.
Is that going to be in the book?
They'll have something like that in the book. Okay, let's look at a vertical line test one here now. So number 9. I can use a vertical line test to determine whether each relation is a function. Okay, remember, vertical line means if I draw a vertical line down here, it can only ever touch that vertical line once. So there's a vertical line, there's a vertical line, there's a vertical line. Is number 9 a function, yes or no, Katie? Yes, 9 is a function. Okay, it would pass the vertical line test. What about 10? If I draw a 10 here,
Yep. No.
does it touch it more than once?
Yes.
Touches there and there. So we would say that is not a function. Okay, not a function. Let's try 11. If I look at this one, function or not a function? Rob, what do you think? Yep, 11 would be a function. That'd pass the vertical line test. Good. What about 12? Function or not a function, Katie? That is not a function. Oops. That would not pass the vertical line test. So we would say not a function. Yeah, I could draw a line right here and it touches that vertical line twice. So not a function. All right. Take a couple seconds to try these 3 on your own. All right. Determine, is it a function or not a function? All right, so let's look at 13 here. I have 0, 5, 1, 4, 2, 3, 3, 2. Kyle, function or not a function?
Function.
That would be a function. Where are we always looking at, Kyle, to determine?
X value.
Yep, looking at the x values. We're checking, do the x values repeat or not? That's the key. 14, function or not a function, Bell?
Zero.
That is not a function. Nice job. 2 of them actually repeat here. If I look, 3's repeat, and my 2's repeat. So that's not a function. 15, function or not a function, Jake King?
Function.
That'd be a function. Yep, looking at my x values, they do not repeat. All right, domain is my what values, Jake O'Connor?
Like the X.
Domain's the x, the range is my
Y.
y. Good work. Here's your assignment.